All right. Atomic structure part 2. Right? We're talking about the periodic table. We did talk about matter and atoms in the last video. There should be a link in the description if you need to go back to the last video. We had a lot of questions too. A couple of students asked about electrons and nucleus. So and it's a great question actually. It was, since the electrons are negative and the protons are positive, why don't the electrons fall into the nucleus? And it has to deal with quantum mechanics. Let me write that down. Let's use blue right up here, right? Quantum. Oh, that doesn't work. Let's try yellow. Yellow should work, right? There we go. Quantum mechanics. And I will talk about why the electrons don't fall into the nucleus in another video. Actually, the next video, it'll be part 2B, right? So it has to do with quantum mechanics. But let's talk about the periodic table. And we're talking about elements, right? And so from the last video, I said anything that has mass and takes up space is matter. And we know that the basic form of matter, and we should change the pen, right? We use red on yellow. So we know that the basic unit of matter is atoms, or are atoms, right? Are atoms. And so when we're talking about elements, we're talking about one type of atom. When we're talking about silver, when we're talking about gold, copper, that's an element because it's one type of atom, or hydrogen or oxygen. So in general, we can say the structure is the atom. We're all made of atoms, right? So gold is made of atoms, and gold itself, the type, is the element. So it's almost the same thing, right? An element of gold has atoms in it. An element of hydrogen has atoms in it, and so forth. And here's our friend hydrogen. As you can see, hydrogen, let's get the pen going again. Hydrogen has only one proton and one electron, and it has this one ring, which we talked about in the last video. So it has this one ring. And we call it ring for teaching purposes. So you can say ring, you can say cloud, you can say orbit, you can say shell. People use shell a lot. You could say energy level. And it has one. Now, we're talking about regular atoms here, not charged atoms. Charged atoms have a charge to them. Those are ions, and we'll talk about those in other videos. So we're just talking about, and when we say regular atoms, we just mean atoms with no charge. So here it is. It has one ring, one cloud, one shell. And here we have a messy desk. So why do we have a periodic table? Basically, what is a periodic table? It's just a way to organize the elements. So let's write that down. We'll write that down right here. I'm going to switch the color. I'm going to use blue. So the periodic table created by Dmitry Mendeleev. I'll write down his name in a minute. So the periodic table is made to organize elements. We have all these elements and we have to organize them. You don't want this desk. Imagine this was a doctor's desk and he's looking for your evaluation on your physical, or this was your teacher's desk and he can't find the paper you gave him. You don't want that, or your lawyer's desk. So we want organization. And I said Dmitry. I'll write his name now. Dmitry Mendeleev. Dmitry. That I's missing over there. There he goes. Mendeleev. And that's two E's there. Dmitry Mendeleev, about 1869, he organized this periodic table based on states of matter at first. So 1869, 4 years after what? What do you think? After the end, something major in American history, of the, you guessed it, Civil War, right? about 4 years after the end of the Civil War. So he organized it first in like states of matter. So we know the basic ones. We have solid, right? We can make a solid ice cube. There is our ice cube. Maybe it's melting over there. We have our liquid, right? Like our water. There's our water everywhere. Is water wet? Well, that's a question. We have our gas. We can't see it. Our gas, right? Well, let's just make these little bubbles. Our gas. We also have plasma, like lightning. Lightning. Let's see if I can make a lightning bolt. Somewhat like that. There's our lightning. All right, we need Thor for lightning. There's also others, right? So these are the four major ones, but there's also others in between. For example, like Jello. What do you think Jello is? So Jello is in between a solid and a liquid, right? It's called a colloid, as you can see up there. So there are other states of matter, but for the main parts, we have those four. And so Dmitri Mendeleev was just organizing them into those states of matter. And here it is. So as you can see, we have all these elements. These are all the elements, right? Some are natural, some are not natural. Some are created in the laboratory and they don't last long, but we'll talk about that in other videos. So as you can see, and get our pen going again, right? We'll change it to red. Here's hydrogen way over there, right? And there's helium over here. So these two that I just circled are the two most abundant elements in the universe. Not so much on Earth, right? We have hydrogen on Earth, right? But oxygen is the most abundant in our crust. It's over there. And nitrogen is the most abundant in the air. So as you can see, there's this big space between hydrogen and helium. But the way it's organized is rows. So we have our rows, which go from left to right. Right? So think when you're rowing a boat. When you row a boat, and some students have used this to remember, you row in the water either left or right? Or straight, right? But you're not going up and down. So the rows are left to right. So here's the first row. As you can see in the first row, there's only two elements. The first row has two elements. That's it. And then, so this will be the first row, the second row, the third row, the fourth row, the fifth row, the sixth row, the seventh row, and so on. So you can see the rows are left to right. And there's something very important of why they're in the first and second and third row. So let's clear that out. Clear it out. The reason why is because the number of rows, and let me write it here, the number of rows will tell you how many rings it has, or orbits or shells, whatever you want to call it. So for example, hydrogen's in the first row, so it must have one shell or one orbit. And it does. It only has one shell. It only has one orbit. Same with helium. Helium only has one shell. Whereas lithium here in the second row will have two shells. Let's look at a picture. All right, here's helium, which is a noble gas, and it has one, make sure our pen's working, it has one orbit. It has one shell, whatever you want to call these. It has one cloud. That's it. So it's in the first row, right? And here's lithium. Lithium is in the second row. Well, how do we know? Well, let's look at the model, the Bohr model. Remember Niles Bohr we talked about in the last video? It has two. Let's count them. One, two, right? And this is the nucleus. This is not a shell. So it has two rows, two rings, I mean. So it should be in the second row, which it is. Let's look again. Okay, make sure our pen works. There's lithium, second row. It has two orbits, two rings, two clouds, and so on down the list. Here's oxygen. What do you think oxygen? How many orbits does oxygen have? Well, it's in the second row, so it has two orbits, two clouds, two rings. And you can just go down the list. What about potassium? Potassium is in the fourth row. So how many orbits do you think potassium has? You guessed it. It has four rows. Well, it's in the fourth row, It's in the fourth row, so it has 4 rings, or clouds, or orbits. What else did we say? Who remembers? Energy levels. Right? And let's count them, right? There's 1, 2, 3, 4. All right. So if we go back to the table, we can see that if we know the row, we know how many shells, orbits, energy levels it has. So let's see if you can answer this question. We'll go to zinc. Let me get our pen going. Here is zinc. I'll circle zinc. How many rows, how many rings and orbits does zinc have? You got to be careful because some students, they see zinc and they see nothing on top and they think it has only one. But no, it's not in the first row. So, and then they say, well, it's in the third row. No, because they forgot that helium's over there. So make sure you do this carefully. 1, 2, 3, 4. Zinc is in the fourth row. So it should have 4 orbits. And I'll leave that up for a minute. As you can see, just go around, look around the periodic table. You can tell by the rows how many clouds it has. But we also have columns. So columns are up and down. And by the way, the rows, I'll write it over here. Let's change the pen. Use that color. The rows, which you know go left and right, are also called periods. Also called periods. And then we have our columns. Now columns go up and down. And they're also called groups. Sometimes you'll hear them as families, because the columns really have a family. And we'll talk about this one right here. I'm circling, trying to circle anyway. So they have a family. These are the alkali metals, which I'll write down. Let me write that down. All right, here they are. So when you're talking about a row, again, I'm saying this a few more times so it sinks in. The rows tell you how many orbits it has, and the columns tell you if it's related, if it has some kind of family. And they do. These are the alkali metals, right? And they all related to each other except for hydrogen. It's all alone. It's not, they put it there, but it's not an alkali metal. It's all alone, all by himself. He likes it that way. So we have lithium, or we have sodium, potassium, rubidium, cesium, and francium. These are all related. These are alkali metals. And we're going to talk about each type of group in other videos. We're going to take them one at a time. So for now, just basically, alkali metals are soft. They're metals. That's the key word there. They're metals. And they're soft. They're soft metals, and they're highly reactive. They're highly reactive. And for example, sodium reacts very violently with, where are we? Where is the chlorine? There it is. There we are. There's the chlorine. So it reacts, and when you put sodium and chlorine together, you get table salt, which we will talk about. All right. And by the way, this group over here with fluorine and you think of fluoride in your toothpaste and chlorine, these are halogens. And we'll talk why they react well with the alkalis. Again, with the table salt, like sodium by itself is very dangerous to eat. If you eat sodium, it reacts very violently with water. And chlorine is a gas. So sodium is a solid, chlorine is a gas. And that's how the periodic table moves. It moves from these metals to gas. So it's moving this way as far as metal to gas. Metal to gas. And you also may be wondering, why is scandium right over here? Why is it there? Why isn't it up here? Well, we know it's there. Why? Why do you think it's there? Right? Why is there these spaces here? Well, because, what do you think? It's in the fourth row. It's in the fourth row, so it has 4 rings. And it's also in this group over here, which are rare earth metals, which, again, we'll have separate videos for each one. And there's scandium, right? Just count the orbits, count the rings. 1, 2, 3, 4. So it's in the fourth row. And what's another name for row? Period. Excellent. Now, the next part is when you see the periodic table, you see these little boxes with these numbers and these symbols. So this is phosphorus. It has a symbol P. That's easy to remember. P for phosphorus. So it'll have its symbol in them. Then it'll have these numbers. And the top number over here, 15, that's the atomic number. They call it the atomic number. And the atomic number only says the number of protons. The number of protons. So how many protons does phosphorus have? It has 15, right? And then it has on the bottom over here, and sometimes they'll put a little number over there, but for the most part, on the bottom, they have this long number here, and that tells you the atomic mass. And the atomic mass is the number of protons. And what binds protons, if you remember from my last video? What binds them together? Starts with an N. You got it, neutrons, right? So it's the number of protons and the number of neutrons combined. And that'll give the atomic mass. And you see that it has this kind of decimal here, so they rounded it to 31. Just rounding it. So again, protons have a positive charge. Electrons have they do have mass, but it's so insignificant that they don't put it in the chart. And then neutrons have no charge. They have no charge, and they help bind the protons together because, again, protons by themselves, if there was only protons in here, they would just quickly go away from each other because they have the same charge. And that, by the way, that binding is called, and we'll talk about this in other videos later on, the strong force, the strongest force we have, the strong force. All right, so what do you think this says? Right? What is the O for? Want to make a guess on what O is? Oxygen, right? It's easy. By the way, it doesn't always work that way because there's a lot of elements that have a Latin root. But yes, this is oxygen. It even says oxygen right there, so sometimes you don't see it that way. And so what is this top number again? The atomic what? The atomic number. And what does that tell you? The number of protons. So there's 8 protons. And this bottom number is the atomic mass. Exactly, you knew that. And it's the number of protons and neutrons, their mass. Not the number of them, but their mass combined. For the most part, it's about 16. And neutrons usually have a slightly heavier mass than a proton. Now, for the most part, we're talking about non-charged atoms in the periodic table. Non-charged. They don't have a charge to them. And so when we're talking about non-charged atoms, what you can usually do is if they have 8 protons, they're going to have the same number of electrons. So how many electrons do you think oxygen should have? Should have 8. Let's bring phosphorus back up. Again, how many protons does phosphorus have? 15, right? You see it. It says right there it has 15. So how many electrons should it have? It has 15 protons. So it should have 15 electrons. Again, very important. This is for non-charged atoms, or sometimes we say regular atoms. The charged ones are ions, which we'll talk about in other videos. So an ion, for example, will have either more electrons or less electrons. Now there is a way to figure out. There's a formula to figure out the number of electrons in a certain atom, and we will do that. We'll have a special video on calculating that number of electrons. But for the most part, if you know the number of protons, you know the number of electrons. But how about the number of shells? So again, from the last video, I said the first shell, call it shell or orbit. By now, you know there's many names for it. First ring can only hold up to 2. And the second one can hold up to 8. And the third one can hold up to 8. So how many rings do you think phosphorus has? Just by looking at this. Did you guess 3? Yes, it should have 3. Let's look at a model. And here's our model. Let's count. Let's get that pen working here. So here's the nucleus, right? You can see it has 16 neutrons, 15 protons. That's the atomic number. If we combine these two together, we'll get the atomic mass, basically. So it has 1, 2, 3. It has 3. Now, in the other videos, we have to talk about how these electrons are arranged, how we can calculate them, and also there's things called subshells. There are shells within shells, or orbits within orbits, which we'll talk about in other videos. All right, and so if you look over here, just bringing this thing up here, you can notice that there's group 1, group 2, group 3, group 4, and so on to group 18. There's actually other types of groups that we'll talk about in other videos. There's also like a 1A and a 2A and an 8B group and so forth like that. For the basic part now for this video, you know there's group 1, which basically is the alkalis, not including hydrogen, group 2, and so forth. And like right now, here's group 12, right? That's zinc. And then we have these metalloids, which don't follow a pattern. They don't go straight down. So we'll talk about the metalloids also. You see, it's like almost like a staircase. So we'll talk about each one. There's many other types. There's the lanthanides, which you can't see, which on the bottom here, and the actinides, which is those radioactive elements. Let's get that picture back up. Here's the lanthanides. We'll go over. And you can see on the bottom, these are the actinides. And if we got my pen there, you can see, oh, there's uranium, which you know from nuclear weapons, and plutonium, right, in nuclear weapons. All right, so we're going to talk about each category in the next videos.